The following is a selected video from yourteacher.com, where you can browse over 450 complete math lessons with example videos, interactive practice problems, self-tests, and more. Try a complete lesson today at yourteacher.com.
Into a headwind, the plane flew 2,000 miles in 5 hours. With a tailwind, the return trip took 4 hours. Find the speed of the plane in still air and the speed of the wind. Let's start things off by setting up a chart based on the formula rate times time equals distance for the two trips that our plane took, into a headwind and with a tailwind. If we use the variable p to represent the speed of the plane, and w to represent the speed of the wind, then remember from the previous example that we can represent the speed of the plane into a headwind as p minus w, and the speed of the plane with a tailwind as p plus w. The time for the headwind trip is 5 hours, and the time for the tailwind trip is 4 hours. So based on our formula, rate times time equals distance, the distance for our headwind trip is 5 times parentheses p minus w, and the distance for our tailwind trip is 4 times parentheses p plus w. Since we know the actual distance that the plane flies in each direction is 2,000 miles, we can set each of our two distances equal to 2,000. So we have 5 times parentheses p minus w equals 2,000, and 4 times parentheses p plus w equals 2,000. As our next step, I would divide both sides of the top equation by 5 to get p minus w equals 400, and divide both sides of the bottom equation by 4 to get p plus w equals 500. Now our system of equations is set up in a familiar way, and we can use addition to solve it. Notice that when we add the two equations together, the w's cancel, and we have 2p equals 900. Divide both sides by 2, and p equals 450. To find w, plug 450 back in for p in either equation, and you'll find that w equals 50. So the speed of the plane is 450 miles per hour, and the speed of the wind is 50 miles per hour.